Okay, we're going to be calculating the integral of from minus infinity to infinity of 1 over 4x squared plus 5. And we're going to use complex analysis to achieve this task. We're going to first see what the poles are. So the poles, there are going to be, let's set up the camera. Okay, poles. We're going to first define the complex function. Of course, it's going to be 1 over 4z squared plus 5. The poles of 4z squared plus 5 equals 0. So 4z squared equals minus 5z. This is squared equals minus 5 over 4 squared. So c equals plus minus I square root of 5 over 2. Okay, so now we have the poles. We can use this by using Cauchy's residue theorem. First, let's see what the contour we're looking at. We're looking at a semicircle, the upper half plane, and we have the pole at I times square root of 5 over 2. Okay, so this is where we're at. Now we have encircled the pole. We can name our parts of the contour. This is gamma 1, gamma 2. This is going to be from minus r to r as r goes to infinity, and this is from Jordan's lemma. This goes to 0, so gamma 1, we can just say that this goes to 0. Okay, so now we're going to calculate the contour. So the contour integral is 2 pi I times the residues of f of z. Now we know that the residues inside the contour is I times square root of 5 over 2, so we can just use that. So this is 2 pi I times the limit as z goes to I times square root of 5 over 2. So right here we can do z minus I times square root of 5 over 2, and as we put the pole here, we're gonna get 0, so that doesn't really matter. And at the bottom we have z minus I times of 5 over 2 and z plus square root of 5 over 2 times I. Doesn't matter if you put it the other way. And we can, and this works because we have plus and minus, and that's the poles. Okay, so now these cancel, and we can replace z with I times square root of 5 over 2. So we're left with 2 pi I over 2 times I square root of 5 over 2. These cancel, and the i's cancel, so we're left with 2 pi over square root of 5. Okay, and that's where we're at right now. The contour integral is 2 pi over square root of 5. Now let's finish it off with noticing that gamma 2 is just the integral from minus r to r of the original integral. So this is just I, and that means that the original integral is 2 pi over square root of 5, and that is the answer.